All right. Thank you, everyone, for hanging around for a few minutes. What we wanted to do, since we have such a busy schedule this afternoon, is just allow some of the members of the press who join us this afternoon to ask some questions to each of you, since we won't have time to do a lot of interviews throughout the day. So we thought we'd spend maybe 20 minutes or so just opening up the floor for some questions from the press. So if anyone has any questions, we'll pass around the microphone. Just introduce yourself, who you are, and where you're from, and feel free to ask away.
Hi, everybody. Thanks for being here. My name is Stephanie, and I'm a student in the broadcast journalism at Emerson, department at Emerson College. And my question for you is that I've heard the term superior society thrown around when it comes to genetics, that we could possibly, like through genome sequencing, we could possibly create a superior society. So what does that mean, and what's wrong with us now?
Well, I think the words.
One of the things that's happening is that with genetic testing that's been developed even some decades ago, there is often testing either prior to pregnancy or during pregnancy that leads to a view of the possibility of Down syndrome, and quite a few parents would choose to terminate those pregnancies. So I think that statistically what's ended up happening is that the incidence of Down syndrome has declined in the Western world fairly substantially since that kind of testing came about. So that's not necessarily saying, you know, everybody needs to be an Einstein, but it does say that there are very serious medical conditions where people at least might be given the choice as to whether they wanted to continue those or not. And so to the extent that in the past you didn't have that choice, the technology might now make it somewhat more possible to have some of those choices.
There is a history of genetics, attempts to create a superior society through breeding. You might check out the repository for germinal choice, which closed down some years ago, and it was an attempt to collect superior sperm samples for artificial insemination. And there's a book written about it called the Nobel Prize Sperm Bank, and it gets into some of the history. But I don't think that's particularly a topic that any of us are interested in here.
Made in general into something very specific. That's the only thing I care about. So she can ask me any question she wants.
Is kind of problem. If you said better society, then we might say, well, maybe if we handled the choice of drugs we take, the lifestyle choices, many of the things we've been talking about here that we are interested in, that would result in a more cost-effective healthcare system, which some might say is a better society. Longer, healthier lives, which would be a better society. It's just that when we use the word superior, it immediately conjures up the idea of actually changing the germline, which is probably neither necessary nor even economically or ethically desirable. I mean, it's much easier to change us as adults.
The goal is more personal information and more personal choice, not society imposing choices.
Right.
Yeah.
I'd really like to echo that too. I think no one is trying to create different and better forms of humans. I think if you go to the pediatric ward and you see small children dying of lipid storage disorders, and then you imagine a society where we've screened those carriers and there isn't a big pediatrics ward with all those terribly sick children, that's a better place now. It's a better society. It's certainly better for the poor resident who's taking care and will probably watch his patient die. That's a sad place. So we're really only talking about preventing some things that everyone agrees are terrible things and that are now in our power to do something about. So I think I agree with George. Better is a really good word, and superior is a little bit of a difficult one.
Hi, my name is Beth Pariseau. I'm a senior news writer with SearchStorage.com. I write about data storage. And the reason I'm here today is because bioinformatics are one of the biggest contributors to the growth of digital information in the world. So any of you that might have any experience or knowledge about this, particularly those of you who are running businesses and trying to store this information for people, can you talk a little bit about the challenges of storing the amount of data that gene sequencing produces?
I can address that. Yeah, sure. It was a much bigger problem a few years ago when
the early next-gen sequencers came to market, and any user of those systems wanted to look at the raw data because it was a brand new science, and they didn't understand exactly how to interpret the image data that was coming off the sequencers. But that didn't last very long because the throughput went up so quickly that you couldn't look at the images because of the data storage requirements. You couldn't move them over the networks. And so in the past 3 years, what you've seen is a constant reduction in the size of the data that gets thrown off a sequencer. And there's no customers we have now, or the very rare one, that looks at images at all. So we're able to process the data real time on the sequencer, and the results that come off can be stored on just routine disk drives. So individual genomes are not a problem to store. Now, if you're a large laboratory like a LabCorp and have a vision of being a center for doing whole genome sequencing in the future, then clearly if you're going to be storing millions of these, you're going to have a data storage challenge. But we continue to work to the point where you can reduce each base in the genome to 1 byte of storage data, including all the quality scores, and that's the goal.
But in practice, I think, since it's still an evolving field, people aren't throwing away the over-sequencing yet, and right, you're still keeping 30x per genome, and that ends up being a fair amount of data.
That's bigger.
I find that in our academic lab center, we're spending almost as much on computers and storage as we are on the sequencing hardware at this point, and so it's starting to achieve parity as a.
Yeah, that winds up being a file of about 50 gigabytes. To store all the reads, and that gives you the ability to reprocess it anytime in the future if the algorithms get better. If you reduce it to just a single base representation of the genome, you've lost any additional information that was in the full collection of reads.
Kevin Davis from BioIT World. Many of you, probably most of you, have done one of the consumer genotyping tests before you had your genome sequence, 23andMe or one of those. And I'm curious whether you, comparing the information that you got from those tests for a few $100s versus the information you got from a full genome sequence, whether you were impressed or maybe even slightly disappointed in the extra level of actionable or recreational information you received from the full genome sequence versus your genotype.
I had the Navigenics test done, and I actually would say that the experience was very interesting, but the information that came back wasn't very helpful. I had restless leg syndrome like the other 250 people in my company that took the test. And so that in and of itself was interesting, but not very enriching. The sequencing, though, because we really approached it more as a medical examination and how we've kind of approached it and worked it, has been far more rewarding. And we've gotten into protein expression, issues of that nature, or protein not being expressed and the like. And it has been just far more clinical and far more interesting relative to why I'm a certain way, and looking back to my parents and where it could be, and again, just more clinical in nature.
I think Anne could speak to that as well.
I found that the genome sequencing data was a lot more precise. I was trying to locate recombination points in my family, or places where chromosomes exchange DNA during meiosis I. And I found that I was able to locate, using genotyping data, these crossover regions to within a few thousand bases at best, and with sequencing I could get it down to less than a few hundred.
My name is Lisa. I'm from Russia, 5 National Channel. Esther, would you tell us a few words about 23andMe program and its aims, please?
I'd be happy to, but I think it's probably more appropriate for me to do that to you alone after the press conference. Is that okay? Yeah, thank you. And I can even do it in Russian, but I won't do that for everybody here.
Show off the new trick.
Hi, my name is Ala, and I'm with Nature. And I guess this question is for, is this working? Specifically for, addresses things that Esther Dyson has said, and George Church in the West as well. So there's kind of a long history already of people knowing what their risks are and not doing a darn thing about them. And it seems like I don't see why sort of on a mass level there's any reason to think that this is any different. So why what do you think about that? Is there a different kind of education that has to happen, or is it just going to be the same?
I think there are, I don't know the numbers, but there's a top bunch of people who don't, is this thing working okay? Who don't need the spur of personal information to do things. And there's a bottom tier of people who it doesn't matter. But in the middle, I see in my own behavior, not so much with my genome, but my Zero Sleep monitor. I think at night, I get better numbers when I wake up in the morning if I go to bed early. And so I think your genome in combination with other things, for a lot of people, will make a difference in motivation, in the precision, in understanding how things work. I also want to tell a story, very brief. There were two guys interviewed. They were brothers, a drunk and a bank president. It turns out their father was alcoholic, and the drunk, when he was interviewed, he said, you know, with a dad like mine, what could you expect? I'm a drunk. The bank president said, you know, with a dad like mine, I turned out really well, because with a dad like mine, I knew what not to do. So knowledge helps some people, it doesn't help others. It's not magical, but I believe that the more you know and the more precise and the more personal it is, and the more you understand that the things you do have consequences. It's not when you're 90, but these changes are happening now. At least some people will be making the right choices about big things and also about small things.
I can say something about this as well. You know that, for me personally, when I also had a rare variant for cardiomyopathy come up in my genome, and maybe I could have guessed it based on the family history, but it's one thing to know. And I'm a numbers guy, right? Got a degree in math and physics, and so I understand probabilities and all that. But still, it's one thing to know that there's a family history and my chances might be increased. But it's quite another thing to know that I got the allele. And knowing I had the allele sent me to the cardiologist to, get an ultrasound taken and, we'll monitor it more closely than I would otherwise. And so there's something about the concreteness of the knowledge and knowing that you personally have it that I think adds a lot of value and is different than what one gets from just having a family history. On the other hand, knowing that it had increased risk for other heart diseases, the doctor said you should be on statins now, even though the formula says no. And I've actively disobeyed that one so far, and I'm taking more time to think about that. And so there's one case where, it pushed me to spend a little more time with the doctors, and another case where it's I've decided to disobey for a bit as I try to figure out whether I really want to be a patient for the rest of my life. Still sorting that one out.
I could really add a comment on that because there was a case recently published in JAMA where someone with a rare cardiomyopathy gene became a semen donor, and he probably shouldn't have, because 23 years later, as the cohort of his children was put together, a child who died at 2.5 was found, 3 more in their teens with diagnosable and active cardiomyopathy were found. And so there's a level where responsible people at least can respond to the knowledge in these genome studies and say, well, have your own family, have your own life, good luck with your possible disease, but hey, don't transmit this where it doesn't need to go. And I think a very good lesson can be learned there, again, that the future, 2-3 generations from now, need not have a set of cases of disease that have just been prevented by calm, rational, reproductive decisions.
Take another question.
I'm Aaron Rowe. I'm affiliated with Wired and Chemical and Engineering News. Once there's a large amount of genomic data in the public domain or otherwise accessible to researchers, do you think we'll see an explosion of boutique companies that will be trying to find siRNA targets, gene therapy targets, and then maybe validating them using other high throughput methods?
Presumably, yes, but the diagnostics is a little bit cheaper right now than therapeutics. But there'll be a lot of activity, both academic and commercial.
And what sort of technologies might complement the genomic experiments that we hope to see in the next few years?
Well, one that I think is going to be important is that there's going to be a lot of people who don't want their genome sequenced, either for personal, ethical reasons, and I I don't think you can, put a value for or against that. It's just a fact. And so I think there's going to continue to be room for technologies that measure small amounts of genetic information and do it rapidly and quickly. And so once you're in the doctor's office and the doctor has a specific question about you, should I prescribe this drug or not? Or maybe you have a family history for a specific thing, we want to check it. And it only requires interrogating 50 or 100 SNPs, a small fraction of the genome. And I think people will be much more comfortable with that than with having their whole genome done. And so there's, these technologies to measure small amounts of genetic information are going to continue to evolve and be important.
Is Fluidigm working on any kind of point-of-care device or?
You have to talk to them about that. I don't wanna